Good day. Viewers all over the world. We are still under second order linear homogeneous differential equation. We are also homogeneous differential equation 2. We just want to continue with the examples and solutions of second order linear homogeneous differential equation. Like what we have here, this example 4. This same thing as m squared minus 7m. No, this same thing as y prime prime minus 7y prime is equal to 0. So if you find the characteristics equation here, the characteristic equation will be m squared minus 7m equal to 0. Of course, this quadratic equation. M is common here. We say m minus 7 equal to 0. So m is equal to 0 or m minus 7 is equal to 0. So m to 0 or m is equal to 7. So m is equal to 0 or 7. So in this case now, we realize that the characteristics equation has different solution. So the solution is, we say y is equal to, we can use any constant, the first one, maybe c1, or we can say c1 or a or whatever constant, c1 exponential mx, that will be 0x, plus c2 exponential 7x. Of course, here, anything raised by 0 is 1. So we have this one is the c1 plus c2 exponential 7x. That will be the solution to this differential equation. That will be the solution to this differential equation. So let's take another example. Say example 5. Or no, this type 1. This type 1. The first example 4 is type 1. Example 4 is type 1. So let's take another example, which is where we are going to have type 2 differential equation. So example 1 is type 1. So let's take another example where we are going to have type 2. Where we are going to have type 2 as the example. So that's what I'm about to write now. So solve. Okay, we have solved. This is 9. So how do we solve this? This is another example. This is another example, which is under type 2. This is another example under type 2. So here the same thing as m squared. This same thing as, here is 9. This same thing as m squared minus 9m equal to 0. So the characteristics equation in this case, this is the characteristics equation in this case. Okay. So when we solve this, what do we get? What is common? M is common. So when we solve this, what are we going to get? M squared minus 9m. The question is, no, here is y, okay, equal to 0. That's the solution. So this same thing as saying y prime prime minus 9 is equal to 0. That's what we are going to get. So the characteristics equation will now be m squared minus 9 equal to 0. That's what we are going to get. Okay, that will be the characteristics equation. This same thing as m squared minus 3 squared equal to 0. Difference of 2 squared. We have m plus 3 into brackets m minus 3 is equal to 0. So m plus 3 equals 0 or m minus 3 equals 0. So m is equal to minus 3 or m is equal to 3. So m is equal to minus 3 or 3. So these are the two distinct but real values of m. So what will be the solution? The solution is, in this case now, they have distinct solution here. So here also they have this is still type 1. It's still type 1 because they have distinct solution. The solution will now be y is equal to maybe a exponential minus 3x plus b exponential 3x. That's what we are going to get. So they have distinct solution. Okay, but this distinct solution, we can rewrite this because we can rewrite this in form of hyperbola solution. Because when we have e raised by mx and e raised by x, there's a way we rewrite it in hyperbola solution. But let's just leave the solution in this form. So let's leave the solution in this form. So we have been able to take 2 examples on type 1 where they have distinct solution. We have been able to consider 2. where they have distinct solution. So let's consider another one. Let's consider another solution. Let's say example 6. Example 6. In this case now, where they have same, distinct and same, where they have same and raised solution. Let's see example on that. I want us to see example on that. Where we have to solve y prime prime is equal to 0. This is type 2. Now we have type 2. So where we have y prime prime is equal to 0. What will be the solution in this case? What will be the solution in this case? So the characteristics equation in this case will be m squared equal to 0. That will be the characteristics equation. So if m squared is equal to 0, then if you take the square root, that will be plus or minus. If you take the square root, that will be plus or minus. So m is going to be 0. So in this case now, m is going to be plus or minus 0. Okay? If m is plus or minus 0, so here m1 is equal to m2 and it's going to be 0. So the solution, we can have something like this. So the solution is y is equal to maybe c1 exponential m is 0x plus c2x exponential is 0x. That's what you're going to get. So y will not be equal to c1 plus c2x. Okay? Y is going to be c1 plus c2x into bracket exponential is 0. N raised to the power 0 is 1. So this will be the solution. This will be the solution to this problem. Okay? Then let's take one more example where we are given under type 3. Let's take one more example under type 3. So let's take one more example under type 3 before we close the class. Let's take one more example under type 3. So under type 3, we have to solve 2 the square y all over the x squared plus 4 the y the x plus 3y equal to 0. So this is example under type 3. This is example under type 3. So what do we do here? How do we solve this? That's what we are about to do. What do we do here? And how do we solve this particular question? That's what we are about to do here. So this same thing as 2y prime prime plus 4y prime plus 3 plus 3y equal to 0. So the characteristics equation in this form will be 2m squared plus 4m plus 3 equal to 0. So that's a particular quadratic equation. Can we solve this? 2 times 3 is 6. No, we cannot solve this problem. We can't solve this problem. So what do we do? If we cannot solve this problem, what do? We can go ahead and use completing the square method, or we use formula method. So in this case now, in this question now, a is equal to 2. A is equal to 2. A is equal to 2. B is equal to 4. And C is equal to 3. We now say that m is equal to minus b minus 4 plus or minus square root of b squared, that's 4 squared, minus 4 times 2 ac, 4ac times 2 times 3 all over 2 times 2, 2a. Here we have minus 4 plus or minus square root of 16 minus 4 times 2, 8 times 3, that's 24, all over 4. That's what you are going to get. Okay? So this same thing as minus 4 plus or minus square root of minus 8 all over 4. Since we have minus in the square root, so minus 8, square root of minus 8 is not real, it's complex. We cannot get this directly. Then what do? We break it down as minus square root of 8 times square root of minus 1. So this will be square root of 8 multiplied by I. So this same thing as square root of 8i. The square root of 8 same thing as 2 root 2i. So instead of minus square root of minus 8, I will change it to 2 root 2i. That is, what I'm trying to say is that m will not be equal to minus 4 plus or minus 2 root 2i all over 4. That is what we are going to get there. That's what we are going to get there. So if we divide through by 4, at the end of the day, we have m to be equal to -1 plus or minus square root of 2 all over 2i. That's what you're going to get. So m1 is equal to -1 plus square root of 2 all over 2i, and m2 will be equal to -1, m2 will be equal to -1 minus square root of 2 all over 2i. So these are the two values of m that we have. These are the two values of m that we have. But in this case now, we realize that these values are complex. They are not real. So what will now be the solution? The solution is y is equal to, let's say, c1. We can call the first constant c1 exponential into bracket -1 plus square root of 2 all over 2i x plus c2 exponential -1 minus square root of 2 all over 2i x. That's the value. So that will be the solution that we are going to get. But of course, we can write this when we go through the videos on second order linear homogeneous differential equations with constant coefficient. You will realize that we can write this as this. We can write this as y. We can write this as y is equal to a. I can change the arbitrary constant because there are some parameters that are coming. I can write this as a exponential minus x, then cos square root of 2 all over 2x plus b exponential minus x sine square root of 2 all over 2x. And of course, finally, y is equal to something is common there. E raised to power minus x is common. Into bracket a cos square root of 2 all over 2x plus b sine square root of 2 all over 2x, which will be the final solution. So under type 3, the root of the characteristics equation or auxiliary equation will be complex. And when it is complex, this is how to resolve everything. So I would love to stop here because of our time. Thank you.